2 is derivatives and integrals of vector functions. And the derivatives and integrals work pretty much like you'd expect. So to take the derivative, so here's a vector valued function. To take the derivative, you just take the derivative of this part times I plus the derivative of this part times j. So what's the derivative of e to the 18t?
18e to the power.
Yes, and that's going to be our I component or whatever goes in the first slot. And then this one, the derivative is 9e to the 9t. Thanks. So that's going to be that. Oh, I'm going to go ahead and pull up assignment 13.2a and input that in the first slot. So in vectors. Okay, then it's also asking us to, for part B, it's asking us to sketch the plane curve together with the position vector and tangent vector r prime for the value t equals 0. Okay, so when t equals 0, we have r of 0. So basically, you take this right here and set t equal to 0. So this is going to be e to the 0 in the I direction, and then this is going to be e to the 0 also. So that's just going to be 1, 1. Okay, so this part, is going to go from the origin to the point 1, 1. So this first vector is just going to be that. That's what this vector is going to be, r 0. And then this vector here, you plug in a 0 for in here, and you get 18, 9. If you plug t equal to 0 here and here. So that's gonna, so this is 1, 1. So 18, 9 is gonna be something like that. And the curve is, if you look at the curve here, so you got, this is your equation right here. You try to find some kind of relationship between those, and this first one, e to the 18t, is actually e to the 9t all squared. So if you set, so if x is equal to e to the 9t squared and y is equal to e to the 9t, then this can plug into here, and it gives you x equals y squared. So it's a parabola, and it's going to go something like this. It's going to go like that. And so it's going to be that answer is going to be the lower left. Okay. So that was number 1. Now let's go to number 2. Okay, consider the given vector equation. R of t equals 3 sine t I minus 2 cosine t j. And we're supposed to find r prime. So again, this is just going to be taking the derivative of each part. So what is the derivative of the first one, of this one right here?
3 negative 3 cosine. T. Sine to cosine.
3 cosine t. So the
Cosine.
derivative of sine is, and then the other one, you take the derivative of the cosine, then what, 2?
Cos the
2 sine t.
2 sine t? Okay. So that's going to be the derivative right there. Now, what we discussed last time was if this is a 3 and that's a 2, and there's a negative right there. If this was a 3 and that was a positive +3, then that would be a circle, right? That's what we discussed. That's one of the main things that you need to remember from last time. But you can also argue this way. So you're saying x is 3 sine t. Oh, this is a sine instead of a cosine also. That changes things. And then you have y equals -2 cosine t. Well, if you take x squared, you're going to get 9 sine squared t. And if you take y squared, you're going to get 4 cosine squared t. But if you divide by 9, if you divide x squared by 9 and you divide y squared by 4,
4 equal to 1.
then yeah, that's just going to be equal 1 because this becomes sine squared, and that just becomes cosine. This just becomes cosine squared. And so this, and then we know what this is. This is the equation of an ellipse. So, and it goes out 3 in the x direction from the middle on both sides, and then because that's 3 squared and this is 2 squared, so it's up and down by 2. So the vertices of the ellipse are here, 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 and here. Now, because you have this negative here and this is a sine, then the angle is not necessarily going to, this is not necessarily going to be when t is equal to 0. Okay, so, but what they really want is for you to figure out what happens when t is 3 pi over 2. So hold on a second. Let me input this answer right here, make sure that's correct into the first slot. Or did anybody else already do that?
It works.
Okay, great. Okay, great. So so for this value right here, let's go ahead and calculate for that value right there. So this is, we're going to put 3 pi over 2 in, or 3 pi over 4. So that's going to be 3 sine of 3 pi over 4, and then -2 cosine of 3 pi over 4. Okay, so let's see, 3 pi over 4 is right here. That's 3 pi over 4. And that's 1, that's -1. And this is √2 right here. Okay, so this one, the sine is going to be 1 over √2. And the cosine is going to be -1 over √2. So that's, but there's a negative there, so it's, so it is 3 over √2, comma 2 over √2. We'll put 2 over √2, or √2, I guess, if you could simplify to that. Okay, so here we have our ellipse, and this point is going to be somewhere over here, probably maybe like right there, we'll say. Okay, so that's our R of 3 pi over 4, actually. And notice it doesn't make an angle of 3 pi over 4. That's because it doesn't, this is not a sine, right? This is not a cosine. In order to match up with the angles, or if it was cosine sine, then it would match up with the angles. Okay, but there's a negative here too, so that also messes things up. Okay, so looking at all the answers, it looks like the only one that works is the bottom right, but we can also figure out what the R prime is, or 3 pi over 4. That's going to be 3 cosine of 3 pi over 4, and 2 sine of 3 pi over 4, which is 3 times negative 1 over root 2, and 2 times positive 1 over root 2. So that's negative 3 over root 2, comma 2 over root 2. Okay, and this vector is pointing in the negative direction on X. On the X component goes backwards, the Y component goes up. And this is, for this one right here, this derivative here is going to be tangent to the curve. Okay, so the vector is going to run tangent to the curve. Okay, so it's kind of like taking the derivative with regular numbers. Okay, so the lower right, okay. Any other questions with that one? Okay, let's move on. Derivative of this function. Well, that's all we have to do is take a derivative. Wow, okay. Okay, it's what's the derivative of e to the negative t?
Negative e to the power of negative t.
Excellent. Okay, and then the next one?
Minus 3t squared.
And then this one?
1 over t.
Excellent. Okay, so let's just put that in there. Okay, good. I got it. Okay, so that was pretty straightforward, taking the derivative. Let's go to number 4. And this has more parts to it. So first of all, the derivative, we can dispose of that pretty quickly. That's 6, and then 12t, and then 12t squared. So that's what the derivative is going to be. Okay, now the next one is capital T stands for the unit tangent vector. And that's going to be the derivative vector divided by the length of the derivative vector. And so, and that's going to be the vector that's tangent to the curve. So to find this, what we're going to do is we're first going to, well, it's evaluated at 1. So first thing we're going to do is evaluate this one at 1, which is going to be 6, 12, 12. Okay, and then we have to divide by the magnitude of this. So we calculate the magnitude, which will be the magnitude of this vector. Which is the square root of 36 plus 144 plus 144. So this sum of the squares of those. And I suppose I could have done this easier. Yeah, let me back up and do it easier. So if you factor a 6 out, you get 1, 2, 2, right? And then the magnitude is going to be 6 times the square root of 1 plus 4 plus 4. So that's 6 times the square root of 9, which is 6 times 3, or 18. So dividing by 18 will do the trick. Okay, so this answer should work right here. And then the second derivative, what do you think that's going to be?
Is it going to
Well,
be
there's the
0, 12, 24, t?
Yeah. So pretty much like you would expect it to be. Okay, and then the final one is, I forgot to put little t there, is our prime of t cross product with our double prime of t. So we got to do a cross product here as well. And you want to put this first, so that's 6, 12t, 12t squared, and then 0, 12, 24t. And then copy down the first two, of course, just like before. Okay, so we have these ones. Whoa. Let's see, 12 times 24 is 288. Okay, so that's 288 t squared I. That's this right here. And then this one is 0, yay. And this is 72k. Okay, then we have minus. That's 0. This is 144 t squared I. And this one is also 144. So that's 144 tj. Okay, so we have 288 t squared I minus 144 t squared I. So that's going to be 144 t squared. That's in the I position, or the first position. The second position is going to be minus 144t for the j. And then the only place that a k appears is right here. So that's 72 for the third position. Okay, so put that in as a vector with a vector bracket. That should work. Okay, so that's the final answer for that part. Yeah, so the thing to remember is the unit tangent vector. It's kind of, yeah, okay, so now number 5. Here, we want to find the parametric equations for the tangent line to this curve at the point 101. Okay. And so this right here is the, if you just put this, comma this, comma this, you would have the vector form. So to find the derivative, so the first thing you want to do, so this is finding a tangent line to a curve. So you just kind of remember back to the days how we did this in calculus. The first one is you want to find the derivative to get the slope, right? Well, here the first thing you want to do is take the derivative so that you can get the tangent vector, because the tangent line is going to go in the same direction as the tangent vector. Okay, so, oh dear. We want to take the derivative of this. Who wants to give this a shot? Taking the derivative of this. Or should I?
No, thanks.
No, thanks. It's the product rule. You don't like the product rule? How could you not like the product rule?
Negative 8 to
It is a
the
negative.
power cosine 8t plus
Yes.
plus e to the power of negative 8t. Oh, it's
Sine
time.
8t. But you'll have a negative 8 come out from here, right? So the derivative of cosine is negative sine, and then so you're gonna get that. So you're gonna get that. Okay, that's just the x. Now for the y, the derivative of this one. So this is the derivative of that. Derivative here. You also have a negative 8 e to the negative 8t, but sine 8t, and then plus you have an 8 coming from there, cosine 8t. And then the third one, the derivative of that, oh good, wow. That's just negative e to the negative 8t, good. Okay, so this is going to be the direction vector, but we can simplify this further. Maybe what we should have done first, but it doesn't really matter. Is try to figure out from, okay, this is giving us the point, right? But what do you think we should do? How do we? So it's occurring at a specific point. So we have these expressions in t, which are quite complicated. But what we'd really like is to figure out what number this is. So what value of t will give you this point? Okay, so how do we figure that out? Or is somebody like a really good guesser and can say, oh, I know what the value of t is?
No. Video.
What do you say, 0? Yeah, t equals 0 actually works, but I guess that what we could do is take the expression for x, set that equal to 1. Take the expression for y, set that equal to 0, and take the expression for z, and set that equal to 1. So I'm just taking this and setting equal to the first one. I'm taking that one and setting equal to the second one, and I'm taking this one and setting equal to the third one. Right there. So this is the original curve. And as you can see, well, hopefully you can see that t equals 0 is going to work. It's going to do the trick. So that means the tangent vector at when t equals 0, that's going to be r prime of 0. What happens when you plug a 0 in for t in this expression? What do we get? Maybe I could just do that. So negative 8 e to the 0 cosine 0 minus 8 e to the 0 sine 0. And then here it's going to be negative 8 e to the 0 sine 0 plus 8 e to the 0 cosine 0. And then this last one is going to be negative e to the 0. Okay, so e to the 0 is just 1. And this is 1. This is 0. So that's gone. So this is just going to be negative 8 in the first slot. This is 1, but that's 0, so that's all gone. And then this is 1, and that's also 1, so this is 8 in the second slot. And then this is, wait a minute. Somebody erased the 8 there. Maybe the gnomes did that. Okay, so it's a negative 8. So this is negative 8. Okay, so that's our tangent vector. But you can divide this whole thing by negative 8. So we could actually just use 1, negative 1, 1. So if you divide everything by negative 8, we can always do that. That points in the opposite direction, but that is, I think that's okay. It might be like distorting the message of this, but I think it's still going to be okay. Or we can just use the original here, either way. And so this is the direction vector of the line, and then this is the point on the line. So you can just use, for the x slot, you start with the point 1 plus, so these get multiplied by t. And then for the y, this is the point 0 and then negative t. And then for this last one, it's 1 plus t. Okay, so let's see if that works.
Wow, that was, wow.
Okay, so that's how you find tangent curves. It's a similar concept to what you've been doing all along, except you can divide by stuff and it'll still be, whereas with a tangent curve, it's still more difficult. Okay. With the tangent line and 2 space, you're just doing 1 variable. It's a little different, but it's similar to, this is similar. Okay, let's move along to number 6. At what point do the curves intersect? Okay, any ideas how to do this one? So you have 2 vector value curves, and typically you're gonna, if there's 2 of them, you're gonna put one in T and the other one in S. You could put both of them in, it doesn't really, this variable here doesn't really matter. If you just have one of them, it doesn't really matter what variable you use. If you use an S here, it's still going to be the same thing. Or if you use a T here, T's here, it's still for convenience. So, how do you suppose we can find where they intersect? What can we do?
You make them equal each other.
Exactly. Okay, so you're going to take you're going to take these components and equate them. So you have t equals 7 minus s, and then you're going to equate these two. So you have 3 minus t equals s minus 4. And then those ones, you're going to equate these. And you have 35 plus t squared equals s squared. Okay, so if we just look at the first two, maybe the first two can give it to us. Maybe not. Wait, can it? Or let's see. Okay, so if we subtract 3 from both sides here, we're going to get negative t equals s minus 7. And then divide by negative 1, you get t equals 7 minus s. Oh, boo. Okay, the first two are exactly the same, so that was no good. Okay, so now let's take this right here and plug it into there. Okay, so 35 plus 7 minus s squared equals s squared. Okay, this gives us 49 minus 14s plus s squared equals s squared. Ooh, I like this because the s squareds cancel. Let's see, negative 14s. This combines to be 84. So 14, that's all 0. So that's 0. Okay, so 14s is equal to 84. Divide both sides by 14. What do you get? 6? Okay, so s equals 6 works, and we can plug, and that means that t is 1, because t is 7 minus s, so 7 minus 6 is 1. And it's probably easier to plug the 1 in, so let's plug that in. If you plug a 1 in, you get R1 of 1 is 1, 2, and 35 plus 1 squared. So that's 1, 2, 36. And if you plug a 6 into here, you get the same thing. So you get 1, 2, 36. So 1, 2, 36. Okay, so the next part is, oh dear. The next part says find their angle of intersection. Okay, so somehow you have these two curves, and maybe R1 is like this, and maybe R2 is like that. And they intersect somewhere. And they intersect here at the point 1, 2, 36. And then you want to know, what is the angle? What's that angle right there? Okay, so what do you suppose we should do to find that angle? What are the steps that we need to do? What's the first thing that we should do? Any idea?
Do you find the magnitude of it?
Magnitude of what?
of the vector?
What vector?
1, 2, 36. I don't know.
Wait, this is a point, really. This is a point.
Never mind.
That's okay. Okay, let me give you guys a hint. So this angle between two curves is the same. So the angle is the angle between two curves. It's also equal to the angle between their tangent vectors, or tangent vectors. Okay, so what we should be thinking is, what are the tangent vectors? And how do you calculate the tangent vector again?
Take the derivative.
Yay, so who doesn't want to take the derivative? I think you guys were trying to avoid it because you didn't want to take the derivative.
Kahia said he didn't want
Right?
to.
You don't want to take the derivative of this?
I can take the derivative of that.
Okay, what is it?
It is 1 -1 and 2t.
Good. Now, also, you can take t and set it equal to 1, because that's really what we're after. And so that's 1, -1, 2. Okay, and in the meantime, we have the derivative of the second one, which is what?
That one is -1,
Yep.
comma 1, comma 2s, but then you put a 6 in and it becomes 12.
Yes, so you put a 6 in and that's -1, 1, 12. Okay, so the angle between the curves is going to be the angle between these two vectors, between this vector and that vector. And so, dang, this is really sloppy. I need to boldface that U. Okay, so the angle, I put down the wrong equation too. This equation's fine. So the angle is the inverse cosine of the first vector dot product with the second vector divided by the norms of the two vectors, right? Okay, so what's the dot product of these two vectors? The dot product of this one and that one. So the first one's multiplied together is -1, and then you have -1 times 1, so that's also another -1, and then the last one is
24.
yes, 24, great. And then the denominator, you're going to have the square root of
1
1
squared,
plus
1 squared, and 4.
4, right? So that's going to be the square root of 6, and then this one's going to be the square root of
1, 1, and 144.
whoa. Okay, so the inverse cosine of the numerator is going to be 22, and down here you're going to have the square root of 6 and the square root of 146. And we can put that in the calculator. We gotta use degrees mode. So you got to change the calculator back to degree mode. Otherwise, you'll get a slap on the wrist or something. Okay, so inverse cosine of 22 divided by, and then maybe put parentheses around that. So
42.
So you found it to be 42?
Yeah.
Yes. 42 degrees. Okay, great. So 42 degrees, yay. Okay, number 7. Also, integration of the vectors works exactly like you would think, except you have the plus constant part. The plus constant part basically means you're going to have a constant for the I component, another constant for the J component, and another constant for the K component. Okay, so those constants can be different from each other. Typically, those constants can be different from each other, but typically when you're doing the plus constant part, this will be like 3 constants. Okay, so if you just do the plus constant part, then that's going to be 3 different constants. Okay, so I'll let you guys do I'm just telling you, integration works exactly the same, or I think it's going to work how you guys expect it to work. And so I'll let you guys experiment with that in the homework. Here is one where we're going to do some integration. And here we have r prime of t equals this. Okay, so r prime of t is 4t cubed, and then 5t to the 4th, and then it's the square root of t, but I'll write it as t to the 1/2. So that's our r prime. So our r of t, to find that one, we can take the indefinite integral of each of these, or an indefinite integral, and add a constant on the end. And this constant is actually 3 different constants. So the antiderivative of this would be what?
T to the 4th,
Yes, and then right here.
T to the 5th.
Yeah, and then this one.
Would it be 3/2 T to the 3/2, and then times 2 over 3.
Yeah, 2 over 3 to get rid of that. Okay, good. Good. So, and then plus a constant. But really, this constant on the end, you can write it like that, but really what it means is 3 different constants. Like that, C1, C2, C3. Okay, now, at this point, we have this condition right here. R of 1 is I plus J. So this is R of T. Okay, R of 1 is saying that is 1, 1, 0. If you put a 1 in for T, you get 1, 1, 0. But if you put a 1 in over here into this one, then what are you going to get? That becomes 1 plus C1. And this becomes 1 plus C2. And that one becomes 2/3 plus C3. Okay, so equating this with this, we have 1 equals 1 plus C1. That means that C1's got to be what? Zero, right? Because the only way that this and this are going to be equal is if C1 is 0. And then you also have 1 equals 1 plus C2, which means that C2's got to be 0. I like that. And then this third one, you have 0 equals 2/3 plus C3. And that means that C3 has to be what?
Negative 2/3.
Excellent. Okay. So you just take these 3 values and you plug them into here. So these 3 values go up, plug into there, and you're going to end up with, in the first slot, that's just 2 to the 4th, because the C1 is 0. And in the second slot, you have 2 to the 5th, because the C2 is 0. And in the third slot, you have 2/3 T to the 3/2 minus 2/3, because the C3 is negative 2/3. Okay, so let's see if they accept that answer.
It worked.
All right. That's good. Okay, so, wow, we still have 14 minutes of class left. But we're all done. We're all caught up. Okay, so let's see. So today is one. Yeah, woohoo.